Hello my dear students, this is Akash HD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to learn about the relative velocity in 2 dimension and 3 dimension and the questions based upon it. Okay, so let's first learn the basics. So here you can see the topic is a relative motion. So you can see here motion of one object with respect to another object is called a relative motion. Even you know also, no object in a absolute rest or absolute motion. If we tell earth in rest or motion, if we are standing on the earth, we will tell earth in a rest situation. But if we see the earth from space or from the moon, then it will be in a which situation? Motion situation. That means whether the object at rest or motion, it depends upon the observer. Where is the observer? That's why in a relative motion we can understand all these things in a better way. Okay, let's go to the further. Rest and motion of any object is always relative but never absolute. As I have told you, it depends with respect to which reference we are observing the object. Is it? Let's see here the example. First example, see here. A person sitting in his house is at rest with respect to earth but in motion with respect to moon. Is it? Because when the reference is the earth, rest situation, but the reference changed the moon, the same person came in a motion situation. Let's see the second one. A driver driving a vehicle is at rest with respect to fellow passenger but in motion with respect to a person standing on a road. Okay, so remember this basics. Okay, let's see somewhat mathematically also. So here you can see relative velocity in 1 dimension, 2 dimension and 3 dimension. Whatever we are going to learn in a vector form. That means applicable for the 2 dimension and 3 dimension. Okay, because in 1 dimension vector is not required, only plus minus sign is enough to indicate the direction. Okay, so see here, relative velocity of an object A with respect to another object B is the velocity that object A would appear to object B. So remember that here when we are seeing the relative velocity with respect to object B, then who is the observer? Object B is the observer. So with respect to the observer B, the situation will be seen. Okay, so see here this first one. Velocity of A with respect to B. Okay, so let's take for example, generally I have taken this is the A and moving with the velocity VA in this direction. Okay, and this is B moving in some other direction with velocity VB. Okay, so here remember that here when I will write here velocity of A with respect to B, then what can we write here? Velocity of A minus velocity of B. Here who is the observer? B is the observer. So when we are telling B is observer, B is a observer, that means this observer in a which situation? At rest. Okay, remember that here. Now if we talk about the second situation, see here please, second situation, see. Velocity of B with respect to A is given by, so what we can write here, see, velocity of B with respect to A is given by velocity of B minus velocity of A. Okay, and here who is the observer? A is observer. Okay, and observer in a which situation? This observer will be in a rest situation, because we have seen with respect to A, so A in a rest situation. Here we have seen with respect to B, so B in a rest situation. Okay, remember that here. Whenever we are discussing in a 2 dimension, A and B will be involved in a I cap, J cap, or maybe J cap, K cap, or maybe K cap and I cap. But when we are seeing in a 3 dimension, what will be there? I cap, J cap, K cap component will be there with A also or with B also. Okay, remember that here as I have told you. Okay, is it? Now let's see here other thing. So here you can see the topic is what? Equations of motion in a relative frame. So now see here, if acceleration of one object with respect to another object is a constant, or what we can tell, A relative is constant. A relative means I can tell B with respect to A or A with respect to B. So in a general form I have taken here A relative. Then equations of motion can be written as. So you know very well what is the equation of motion. First equation, kindly see here, v equal to u plus at. This is the first equation. If we want to apply in a 2D or 3D, we have to put here vector form. But same equation can be applied in a relative motion also. So v relative, here we can write here r relative, and here I can write here a relative. Just for the example, like this here. Velocity of b with respect to a is given by initial velocity of b with respect to a plus acceleration of b with respect to a into time here. Now, so b with respect to a, b with respect to a, b with respect to a, relative velocity. Is it? Even you can write here a with respect to b, a with respect to b, a with respect to b. Is it? Remember that here. If we talk about here the second equation, you know very well here. Now in a general form, I can write here delta r, I can write displacement vector, okay. Or I am writing here displacement vector s is equal to, you know very well, ut plus half at square. Is it? So vector, vector, vector. Now again what we can write here? See here please. This is relative. This is relative, and acceleration also relative. Is it? And if we'll just write here, see, in the same way, b with respect to a is given by initial velocity of b with respect to a into time plus half acceleration of b with respect to a into t square here. Is it? And if I write here the third equation, so what is the third equation? You know very well here, v square equal to u square plus 2as. Is it? But I will write here in a vector form. So kindly see here please. I can write here, see, vector v dot vector v is equal to vector u dot vector u plus 2 vector a dot vector s. Okay, and when we are using the relative velocity means I can write here, see, this is relative, this is relative. Now see, all this relative only. Relative. If I take here the example, what we can write here? In the same way, see, velocity of b with respect to a dot product. Velocity of b with respect to a is equal to initial velocity of b with respect to a, again initial velocity of b with respect to a, and then what we can write here, see, to acceleration of b with respect to a into s b with respect to a here. Is it? So remember that here equation 1 and equation 2 is the very important. Most of the time these two equations will be used. Okay, this third equation is the very rare. And when we can use this equation? When what is constant? Acceleration is constant. If acceleration is not constant, then what we have to do? We have to use the differentiation and integration. Okay, can you see here? Now what we will do? We will just solve here some questions. So see here, one basic question is there. See, a bird is flying towards south with a velocity 40 km per hour and a train is moving with a velocity 40 km per hour towards east. What is the velocity of bird with respect to an observer in the train? So you can see very well, observer is inside the train. That means we have to calculate velocity of bird with respect to train. Okay, so let's decode the question here. Here you can see very well, bird is flowing in which direction? South direction. I will take here this basic. What is the basic? Sign convention. Basic sign convention is like this. You see, east, west, here north, and this is the south. No? This is the basic sign convention. Now, according to the question, what is given? Bird is flying in which direction? South direction. So kindly see here, please. This is the bird is there now, and bird is flying in a south direction like this here. Velocity of bird here, south direction. What we can write here? See, velocity of bird is given by what is the magnitude? 40. Direction, you can see downward along negative y-axis. So we have to take here minus j cap. Is it kilometer per hour as it is? Next one, if we talk about here, train is going in a which direction? Towards east direction. Okay, so see here please. Now one train is there. Now this train is there. Train is moving in a which direction? This direction. This is the velocity of that train. Okay, so this is the situation is there. Okay, can you see? Here bird is there and here train is there. Okay, so what is the velocity of the train? We can write here, see, velocity of the train is given by magnitude, same only 40. Is it? So see here 40, and along x direction, what is the unit vector? I cap. Is it? So 40 I cap. Now this thing I think. Now we can write here, see, velocity of What they are asking, bird with respect to an observer inside the train. So velocity of bird with respect to train is given by velocity of bird minus velocity of a train. So velocity of the bird, what is given here? Minus 40 j cap minus. What is the velocity of the train? 40 I cap. Okay, see, 40 I cap. So this is the answer. With the, what is the unit? Unit is the kilometer per hour. But if we check the options, you can see we have to write the in this way here. Okay, so what we have to do here? We have to do like this. See, first we have to calculate the magnitude, velocity of bird with respect to train, coefficient of I cap square, na, plus coefficient of j cap square. So 40 square, anyhow what this will become here? 40 root 2 kilometer per hour here. Is it? Now after that, if we talk about the direction, what is the direction? Direction, remember that here in the question, what is given here? See, minus 40 j cap, see here, minus 40 j cap minus 40 I cap. Okay, so see, if I draw here, see here please, I'm just drawing here, minus 40 j cap in which direction? You can see very well here, this is here, na, 40, I can see the minus 40 j cap downward. What is the minus 40 I cap? This side here, see, like this, this is the 40, is it? So if I draw here like this here, see, so here you can see very well from the parallelogram method, like this it will come here. What is this? This is the velocity of a bird with respect to train. This is the situation. You can see with the diagram way, this one. So you can see very well, no? You can see very well, no? This is 40, this is 40. So anyhow, what is the angle? No? Let's take for example this angle. What is the tan theta? Opposite by adjacent. So you can see opposite is 40, adjacent is 40. So what will come here? This angle even will come 45 degree. But angle is not required. In the question they are asking which direction. So you can see very well, if you compare with this, this is coming. That means like that it is coming here. Is it? That means it is coming which one here? Southwest direction. That means velocity of bird with respect to train is going in a which direction? You can see very well, it is going in a southwest direction. Option C is the correct answer here. Is it? They are asking velocity of bird with respect to train. So which direction it will come? Southwest direction. Is it? Kindly see here. Option C is the correct answer here. Is it? Great. Now let's move to the next one. Here you can see very well. See, car A has an acceleration of 2 meter per second square due east, and car B 4 meter per second square due north. What is the acceleration of car B with respect to car A? Is it? So again we can see here what is the basic we know very well, like this kind of situation is there, you know very well. This is east, this is west, no? This is north, and this is south here. Is it? So you can see very well, if we talk about here the acceleration of the car A. Now so see here, acceleration of the car A is given by 2 meter per second square due east. That means in this direction, east side. That means I cap. So I can write here, see, 2 I cap. Is it? Now after that, if we talk about here the acceleration of the car B, in which direction it is going here? See, 4 meter per second square due north. That means upward along north direction. And what is given here? 4. So north direction means we can write here J cap here. Is it? Now what they are asking? They are asking, you can see very well, acceleration of car B with respect to car A. So see here please, see, acceleration of car B with respect to car A is given by, see here please, AB minus AA. Is it? And remember that here whenever we are not writing anything, that means always with respect to ground only. Is it? Now you can see very well here AB minus AA. What is coming here? You can see 4J cap minus 2I cap. Is it? And meter per second square. But again in the question what they are telling, we have to write in this form here. Is it? So magnitude and direction. Can you see here 4J cap minus 2I cap. Is it? So let's find out here the magnitude and direction. Is it? So as we know, acceleration of B with respect to A, what is given here? See, 4J cap minus 2I cap meter per second square. Is it? So if I talk about here the magnitude, so what we can write here the magnitude, see here, B with respect to A is given by coefficient of I cap minus 2 square plus coefficient of J cap 4 square. So what is coming here? Kindly see 4 plus 16, and it will come here root 20. So when you will simplify this root 20, what this will come here? 2 root 5 meter per second square. Okay, what is this? This is the acceleration 2 root 5 meter per second square. When we'll see here, you can see all this here 2 root 5 meter per second square, 2 root 5 meter per second square. But direction we have to decide. Tan inverse 2, west towards north, west towards south, in which direction is it? So for that, let's see here please how we can get here the direction. So you can see very well here. I'll just draw here the diagram. 4j cap. Okay, so 4j cap, how to draw here? See, this is the 4j cap. See, here I will draw here what? See, 4j cap, no? J cap along north direction. And then what is given here? Minus 2i cap. See here, please, this is here. No, this is the minus 2i cap. This is 2. No. So again, let's draw here the parallelogram and see this angle. No, this direction. No, this is the what is the direction here? You can see very well. This is the acceleration of B with respect to A. How to get the direction? Tan inverse 2 is coming here now. So let's take here this angle. This angle we have to calculate theta. So what this will be? Tan theta. Again, you can see very well. Opposite by adjacent. What is the opposite here? 4. And what is the adjacent is there? 2. So what is coming here? 2. So theta is coming here. How much? Tan inverse 2. Is it? But tan inverse 2. Which direction? You know very well. You know very well. What is this direction? This direction is what here? West. No? This direction is what here? West. Is it? And what is this direction? Guess. This is the direction north here. And how much angle is coming? Tan inverse 2. Is it? So let's see here please. So you can see very well here. Tan inverse 2 from west towards north. Tan inverse 2 from west towards north. See here. Tan inverse 2 from west towards north. No? From west towards north. So which option is correct here? The correct option is here. Option A is the answer here. Is it? So see here. The correct option is here. Option A is the answer. Remember that here. Okay, great. Now students, let's see. Move to the next one here. Kindly see. The question is here. A ship A is moving westwards with a speed of 10 km per hour, and the ship B 100 km south of A is moving northwards with a speed of 10 km per hour. The time after which the distance between them becomes shortest is how much here? Okay, so we can see very well. Let's take one ship A is there. No? This is ship A and it is moving in which direction? West direction. With how much speed is given here? 10. So anyhow write here the velocity of VA. Okay, after that what is happening that here the ship B is where you can see ship B 100 km south of A. No? So south will be this side here. Is it like this is there? No? Here ship B is there. This is how much distance is there? Anyhow 100 km south of A. And moving with how much here? 10 km per hour in which direction? You can see very well. North direction here. Is it like this? This is the north direction. Is it? Can you see here? This is the velocity of B, north direction. Is it? So we can write here. Kindly see here. Velocity of A is given by what is given here? You can see very well 10 and direction you can see here minus I cap. Similarly, what is the velocity of the B? What is given here? This is the 10 km per hour. This is also 10 km per hour, but we'll write here 10 J cap. Is it? Because upward. Now what I am going to do here, I am going to calculate velocity of B with respect to A. So what this will come here? Velocity of B minus velocity of A. Is it? I am going to calculate with respect to A. That means A will be in a which situation? Rest situation. Okay. So VV minus VA, what this will come here? We can see very well. See 10 J cap and minus 10 I cap means plus 10 I cap is there. Is it? So if I write here the magnitude of B with respect to A, what this will come here? Square root of coefficient of I cap square plus coefficient of again I cap square. What this will come here? 10 root 2 km per hour. Is it? So now what is happening that here we are just going to draw here one equivalent situation. Okay. So according to the equivalent situation, what will happen that here now ship A in a which situation? Rest situation, because everything we have calculated with respect to A only. Is it? Now what is happening that here this B is there. No, this B is there. This B. Now this B is moving in a how much direction? You can see very well. 10 J cap plus 10 I cap. So you can see this is 10 I cap, this is 10 J cap, this is the direction. This one here. How much here? You know very well. 10 root 2 kilometer per hour, making how much angle? The angle will be here 45 degree here, now because tan theta equal to coefficient of j cap by coefficient of I cap, 10 by 10 1, tan theta is 1, so theta 45 degree. Okay, this is the thing. So now what is happening that here, this ship is going like this here, okay, like this it is going. In a rest situation, we have to find out the time. For them, the distance between them is shortest. Okay, so what we'll do here, we'll just draw here the one perpendicular like this. Now we have drawn here one perpendicular, and you know very well the shortest distance will be this one here, na, AM. So anyhow, what is this angle? You know very well, this angle is 90 degree. 90 degree. And what is this one here? This is the 100 kilometer, is it? So can you guess what is the value of the AM? No, because time is given by time, no? After how much time? So time means this shortest distance AM, and this velocity of B with respect to A. This is the time will be there. Okay, so what is the AM value? Just use here the triangle. You can see very well, this is 100 is there. Now this side 100 cos 45. This side what will be there? 100 sin 45. So 100 sin 45 means I can write here 100 into 1 by root 2. That is AM. And what is velocity of B with respect to A? You can see very well 10 root 2. Is it? So we can write here very well. This will become here 50 root 2. And this is 10 root 2. So anyhow it will simplify. And then what this will become here? 50 root 2 by 10 root 2. It will become here the 5R. 5R. So which option is correct here? The correct option is here. Option D is the answer. Can you see here? Is it? So students, I hope so. This video based upon the relative velocity in 2 dimension and 3 dimension is very clear to you. Keep studying, keep growing.